So any equation, if you can express it in the form of f of x dx is equal to g of y dy, then when you integrate it on both sides, then that will give you the general solution of the differential equation. What is derivative of 1 by ax plus b form? It is log of ax plus b. So here value of a is 1. We know that by the application of derivative, the slope of the tangent to the curve can be expressed as dy by dx. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am with Vidhyaashram School of Excellence, Mysuru. In today's session, we are going to find the general solution or particular solution whenever the differential equation is given. So here, in your syllabus, you have only the first order, first degree differential equation, or to solve only the first order, first degree differential equation. We have learnt order and degree of differential equation. So here you have to find only the solutions for first order, first degree differential equation. So we have many form of differential equation and many sorts and methods to find out the differential equation. One of the method is the variable separable method. So here we have methods of solving first order, first degree differential equation, and in that we are going to find the solution for differential equation through variable separable. So what is this variable separable? Suppose whenever a differential equation is given, whenever you can express this in the form of f of x dx is equal to g of y dy. That is, whenever the function is given in the form of y is equal to some sort of equation, if you can express all variables of x in one side, all variables of y in other side, then the solution is the integral of f of x dx plus is equal to integral of g of y dy plus c. So this will become the solution for this type of differential equation. So any equation, if you can express it in the form of f of x dx is equal to g of y dy, then when you integrate it on both sides, then that will give you the general solution of the differential equation. So let's take the problems related to this variable separable method of finding the solutions for differential equation. Find the general solution for the following differential equation. First one is dy by dx is equal to 1 plus y square by 1 plus x square. So clearly, see here I have dy by dx and here I have 1 plus y square over 1 plus x square. Let me separate all x variables in one side and all y variables in other side. So then I can write this as dy by 1 plus y square is equal to dx by 1 plus x square. So when you can arrange this in the form of f of x dx and g of y dy, what will be the solution? The integration of the equation will give you the solution for differential equation. So let me apply integration on both sides. Then it is integral of dy by 1 plus y square is equal to integral of dx by 1 plus x square. Now we know that the standard form 1 over 1 plus x square dx is always tan inverse x plus c. So we know that by the properties of integrals, the variables can be changed, but the property is one and the same. It may be x here, it may be y here, it may be z, p, q, anything, but the property is same. Therefore, here integral of 1 plus y square dy can be written as tan inverse y. And integral of 1 plus x square can be written as tan inverse x plus integration constant. So this is the general solution for this differential equation. Next question, dy by dx plus y is equal to 1 here. So here dy by dx, I will take it as 1 minus y. So the condition is y cannot be equal to 1. So therefore, if it is equal to 1, then the derivative becomes 0. That means we can't find the general solution here. So therefore here, let me separate y variables on one side and x variables on the other side. So I'll take dy by 1 minus y and dx on the other side. Let me apply the integral dy by 1 minus y integral of dx plus integration constant. So we need to apply integration constant. Now derivative of 1 minus y. We know that 1 by x dx or integral of 1 by x dx is log x or in the form of log mod x, or like that only derivative of 1 by ax plus b form dx can be written as 1 by a log of modulus ax plus b plus integration constant. So now here only the variable is changed here. This is in the form of ax plus b. We need to write 1 by a. What is the value of a here? The coefficient of the variable a is minus 1. So therefore here it is minus log modulus 1 minus y is equal to, what is integral of dx? If nothing is there, you should take it as 1. So what is integral of 1 with respect to dx? It is x plus c. So this is the general solution for the given differential equation. Next question, y log y dx minus x dy is equal to 0. So let me write this as y log y dx is equal to x into dy, or I can write it as dx by x is equal to dy divided by y log y. Let me apply the integral. Dx by x is equal to integral of dy y log y plus integration constant. Now, so I already said you integral of 1 over x is nothing but log x. So therefore I can write it as log x. So here I have y log y. So what is integral of y log y or dy by y log y? So what happens here? Put log y is equal to t. Then what is derivative? 1 by y dy is equal to dt. So what happens here? So this becomes integral of dt by t. So which is nothing but log t plus c. So what is log t? So log t, here it becomes log of log y. So log of log y plus c. So now here I can write this as log of log y. So then let me take this as log c. Let me take this as log c. We know that log of log y plus log c becomes log x. Since this is a constant, I can replace it as log c. Then it becomes, this is in the form of log x plus log y, which becomes log of c into log y. Now on both sides I have log functions, I can remove it. So therefore it is become x is equal to c log y. So this is the general solution for the given differential equation. So here we can make a use of substitution method. So using substitution method, I will get integral of y log y as log of log y. So next, to make log on both sides, I will just replace c with log c. So that I will use the properties of logarithms log x plus log y as log xy, and I will cancel log on both sides. I will just write x is equal to c log y. Next is dy by dx is equal to e power x plus y. So e power x plus y can be written as e power x into e power y using the law of exponents. So when you have powers as the sum for the same base, then you can split it in its the product form. That is a power m plus n can be written as a power m into a power n. Similarly, e power x plus y can be written as e power x into e power y. Now here e power y I will shift to the left hand side, then this becomes e power minus y into dy, and here it becomes e power x dx. Now we know that integral of e power x dx is e power x plus c. Similarly, if it is in the form of e power ax plus b dx, then this is again 1 by a e power ax plus b plus c. But just here we have changed the variable. So in terms of x, just take y, then you have a as minus 1. So therefore, when you apply the integral here, e power minus y dy is equal to integral e power x dx plus integration constant. So this value of a, because ax plus b, then it must be in the form of ay plus b. What is the value of a here? It is minus 1. So 1 by a becomes 1 by minus 1, which is minus 1. Again it is same, e power minus y is equal to, here it becomes e power x plus c. So now multiply 1 here. So this becomes e power minus y is equal to e power x plus c. So here we have minus. So this is the general solution for the given differential equation. Next question. Find the equation of the curve passing through the point 1, 1, whose differential equation is x into dy is equal to 2x square plus 1 dx, x not equal to 0. So we need to find the solution for this differential equation, and we need to find out the curve passing through the point 1, 1. So that means we have to take the value of x as 1 and value of y as 1 after finding the general solution. So here we have x into dy, 2x square plus 1 is equal to dx. So let me take dy is equal to 2x square plus 1 divided by x into dx, which can be written as 2x plus 1 by x into dx. Now apply integral on both sides. Dy, integral of 2x plus 1 by x dx plus constant. Now what is integral of dy? It is y. So integral of 2x is, it becomes 2 into x square by 2 plus integral of 1 by x is log x plus c. Now 2 get cancelled. So therefore y is equal to x square plus log mod x plus c. So this is the general solution for the given differential equation. Now we need to find out the equation of the curve passing through point 1, 1. So at 1, 1, equation 1 implies, so what does it become? Y should be taken as 1, x should be taken as 1. So it becomes 1 is equal to 1 plus log 1 plus c. So 1 log 1 becomes 0. So we will get c is equal to 0. So therefore the required equation is y is equal to x square plus log mod x. So we need to find out what is the value of c at the point 1, 1 and substitute it back to equation 1. So that will give you the equation of the curve passing through 1, 1. Next, find the differential equation xy dy by dx, x plus 2, y plus 2. Find the solution curve of the curve passing through the point 1, minus 1. The same thing. So here we are going to write xy dy by dx is equal to x plus 2, y plus 2. So let us separate all y to one side, all x to one side. So then this becomes y divided by y plus 2 dy. Here it becomes x plus 2 by x dx. So what I will do here, I will add plus 2 and subtract 2 for this equation. Then I will divide it by the numerator. So y plus 2 by y plus 2 becomes 1 minus 2 divided by y plus 2 into dy is equal to x by x is 1 plus 2 by x into dx. So let me apply the integral on both sides and add integration constant here. So what is derivative of 1 with respect to dy? It is y. Next, we have 2 as a constant. Next, what is derivative of 1 by ax plus b form? It is log of ax plus b. So here value of a is 1. So therefore it is log modulus y plus 2. Next, on the other side, we have 1 into dx, which become x. 2 by x becomes 2 log x. So therefore x plus log x plus c. Now let me take this as equation 1, which will represent the general solution of the differential equation. Now I need to find out the solution at the point 1, minus 1. So at 1, minus 1, That means take x is equal to 1, y is equal to minus 1. So what happens? Minus 1, minus 2 log modulus minus 2 plus 2. X should be taken as 1 plus log 1 plus c. So this becomes 0. So completely this becomes 0. Next we have minus 1. So here this is also 0. So c is equal to minus 2 I will get. Now substitute the value. So therefore it is y minus 2 log y plus 2 is equal to x plus log mod x minus 2. So this is the required solution. Next question. Find the equation of a curve passing through the point minus 2, 3 given that the slope of the tangent of the curve at any point x, y is 2x by y square. The slope of the tangent is nothing but dy by dx. We know that by the application of derivative, the slope of the tangent to the curve can be expressed as dy by dx, and that is given in the form of 2x by y square. Now we need to find the solution at the point minus 2, 3. So let me take it as y square dy is equal to 2x dx. Let me integrate it on both sides. Then this becomes y cube divided by 3, 2 into x square by 2 plus c, 2 get cancels. So I can write y cube by 3 is equal to x square plus c. Take it as equation 1. So this is the general solution for the given slope of the tangent. Now I need to find out the solution at minus 2, 3. So at minus 2, 3, here we have y cube. So y cube is 3 cube by 3 is equal to x square is minus 2 whole square plus c. 3 get cancels. So 9 plus 4 it is when it comes here minus 4, which is equal to c. So therefore what is the value of c? C is equal to 5. See, 3 square is 9, minus 2 whole square is 4, 9 minus 4 is 5. So that was the value of c. So therefore the required solution is so you have to take c is equal to 5, y cube by 3 is equal to x square plus 5, or multiply 3, y cube is equal to 3x square plus 15. So this is the solution at the point minus 2, 3. So next question. Find the particular solution of the following differential equation. Particular solution is nothing but free from any constant. So whenever the differential equation is given, we will solve it using variable separable method. Then we are going to find out the general solution. We know that general solution contains always the integration constant c. So for that, at given point, we will find out what is the value of c and then we'll substitute back, which will become the particular solution, because particular solution should not contain any arbitrary constant. Now we have the differential equation dy by dx is equal to minus 4x into y square, and we need to find out the particular solution at y is equal to 1 when x is equal to 0. So using variable separable method, observe that the given differential equation can be separated or not. Only if they can be separated, this method of finding solution can be applied. So here, yes, we can separate. We can write it as dy minus y square, and here I can write it as 4x dx. Let me integrate it on both sides. So I'll take dy by y square integral of 4x dx plus c. Integration of 1 by y square is 1 by y. So therefore this becomes 1 by y is equal to 4 into x square by 2 plus c. 2 get cancels. I'll get 1 by y is equal to 2x square plus c. So let me take this as equation 1. So when y is equal to 1, so now I need to find out the value of c at y is equal to 1 when x is equal to 0. So equation 1 implies y is 1, so this is 1 is equal to c. So the value of c is 1. So therefore, the particular solution is 1 by y is equal to 2x square plus 1. So this is the particular solution. So finding the integration constant value and substitute it back, you will get the particular solution of the differential equation. Next, cos dy by dx is equal to a belongs to R, y is equal to 2 when x is equal to 0. We need to find out the particular solution at the given points. Cos dy by dx is equal to a. So I'll write dy by dx is equal to cos inverse a. Clearly this is a constant. Because a is constant, cos inverse of a is also constant. Now separate it. Dy is equal to cos inverse a into dx. Apply the integration on both sides. Dy, let me take cos inverse a outside because it's a constant, dx plus c. Integration of dy is y. Here we have cos inverse a. Integration of dx is x plus c. Now this is the general solution. So this is the general solution. Now y is equal to 2 when x is equal to 0. So if you put x is equal to 0, this complete term is 0 and y can be written as 2 is equal to 0 plus c. So this implies c is equal to 2. Now substitute it back to the general equation. So therefore, the required solution is y is equal to cos inverse a into x plus 2. So this is the particular solution for the given differential equation. Next question. X into x square minus 1 dy by dx is equal to 1. Y is equal to 0 when x is equal to 2. So let me write dy on the left hand side. Shift all x square there. It is dx divided by x into x square minus 1. Now x square minus 1 can be written as dx divided by x into x plus 1 x minus 1. Now this is of the partial fraction form here. So we need to find out the solution for this equation. So first, let me express 1 by x, x plus 1, x minus 1 as a by x plus b by x plus 1 plus c by x minus 1. So let me take this as equation 1. Why? Because if I apply integral for this, then this can be solved by the method of partial fraction, because we have a quadratic equation which can be separated into 3 factors, and hence by the method of partial fraction we will integrate this. So now here we have, let me find this. So 1 is equal to a into x plus 1 x minus 1 plus b into x minus 1 plus c into x plus 1. Let me take this as equation 2. Now we have 3 factors here. If you put x is equal to 0, what happens? 1 is equal to 0 plus 1 is 1. 0 minus 1 is minus 1. So we get it as minus a. So therefore we get a is equal to minus 1. Next we will put x is equal to 1. If you put x is equal to 1, what happens? Here this term 1 minus 1 is 0. So the complete a becomes 0. Again this becomes 0 because 1 minus 1 is 0. And here we get 2c. So we get 2 into c. So therefore I can write c is equal to 1 by 2. So this is the value of c. Next is, now let me put x is equal to minus 1. Then this is 1 is equal to minus 1 plus 1 0. So this term is 0. Minus 1 is minus 2. Minus 2 into minus 1 is 2b. So therefore I will get b is equal to 1 by 2. And here the last term becomes 0. So therefore the value of b is 1 by 2. So therefore equation 1 implies 1 divided by x into x plus 1 x minus 1 can be written as minus 1 divided by x plus half divided by x plus 1 plus half divided by x minus 1. So now let me integrate it on both sides. So integral of dx divided by x into x plus 1, x minus 1 is, so integral of, I'll take minus outside, 1 by x dx. Again I'll take half outside, integral of dx by x plus 1. Again I'll take half outside, integral of dx by x minus 1 plus c. So what is this equation? This is actually integral of dy. So therefore here integral of dy is equal to, this can be written as minus log x, and here half if I take outside, this is log x plus 1 plus half log x minus 1 plus c. So now this is in the form of log x plus 1 log x minus 1, and we have half for both. So here integral of dy can be written as y. Here I can write it as minus log x. So this can be written as log of x minus 1 into x plus 1 can be written as x square minus 1. Since half can be recruited into the power, I can write it as log of root of x square minus 1. And we have an integration constant c. See, because this is half log x. Suppose you have half log m, then I can write it as log m power half, which means log root m. So using the property of log x plus log y, I can write it as log x into y. Log x into y means log x plus 1 into x minus 1, which can be written as x square minus 1. And we have half, which becomes the power, whose index is half, means it's a square root. So it is log of square root of x square minus 1. Again we have y is equal to log x minus log y can be written as log of x square minus 1 divided by x plus c. Now this is the general solution. So let me take it as equation 3. So now equation 3 represents the general solution for this equation. Now we need to find when y is equal to 0 and x is equal to 2, what happens here. So when y is equal to 0 and x is equal to 2, equation 3 implies, so y is 0, 2 square is 4, 4 minus 3 is, so this becomes log root 3 divided by 2 plus c. Or I can write this as c is equal to minus log root 3 by 2. So minus log root 3 by 2 can be interchanged as log 2 by root 3. So now substitute the value of c in equation 3. So when you substitute c is equal to log 2 by root 3, then equation 3 implies y is equal to log of square root of x square minus 1 by x plus log of 2 divided by root 3. Or y is equal to log x plus log y form, log of 2 by root 3 root x square minus 1 divided by x. So this is the particular solution for the given differential equation. Next, dy by dx is equal to y tan x. Y is equal to 1 when x is equal to 0. So I will separate dy by y tan x into dx. Integrate it on both sides, adding an integration constant. This becomes log y. Integration of tan is log of modulus secant x plus c. Now when y is equal to 1 and x is equal to 0, so log 1 log of secant 0 plus c. So log 1 is also 0, 0. So 0 is equal to 0 plus c. So this implies c is equal to 0. So at y is equal to 1 when x is equal to 0. So this is the general solution. Now if you put c is equal to 0 in general solution, then 1 implies log y is equal to log of secant x plus 0. So this implies log y is equal to log secant x. We have log on both sides. This implies y is equal to secant x. So this is the particular solution for the given differential equation. Now finding the general solution and particular solution through the variable separable method only possible whenever you can express all y terms in one side and all x terms in one side. So whenever the differential equation is given, you are supposed to see whether it can be separated or not. If it can be separated, you can use the variable separable method finding the solution for given differential equation. And these type of question carries 3 marks in your examination. So variable separable method. So when you can express all x terms in one side and all y terms in another side and you can integrate it, this is the solution of the differential equation which carries 3 marks for in your examination. So we'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.